Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the equivalence of various statements for the second law. First, we should give much attention to the application of the increase of entropy principle. First, the total entropy of the isolated system only increases but does not decrease. However, the entropy of a part of the objects in the isolated system may decrease with the migration of mass or heat. 2. The principle of entropy increase is only applicable to isolated systems and not to non-isolated systems. It seems that its application is limited. However, this is where its universality lies. As long as all objects and all processes are included to form a sufficiently large isolated system, this principle can be used broadly. Third, limitations. It is universal only in limited space. That is, it cannot be extended to the infinite universe. Otherwise, it will lead to fallacy. Historically, there are many statements for the second law. They are equivalent. Any device that violates the Kelvin-Planck statement also violates the Clausius statement and also violates the increase of entropy principle and vice versa. There is a logical inevitable relation between the Clausius statement, the Kelvin-Planck statement, and the increase of entropy principle. They are equivalent. When one statement is correct, the other statements are also correct, and vice versa. A violation of one statement leads to the violations of the others. The topic of this subtask is about the equivalence of the two statements. Consider the heat engine refrigerator combination as shown in figure. Operating between the same two reservoirs, the heat engine is assumed to have, in violation of the Kelvin-Planck statement, a thermal efficiency is 100%, and therefore it converts all the heat it receives to work. This work is now supplied to a refrigerator that removes heat from the low temperature reservoir and rejects more heat to the high temperature reservoir. The combination of these two devices can be viewed as a refrigerator as shown in figure B that transfers heat from a cooler body to a warmer one without requiring any input from outside. This is clearly a violation of the Clausius statement. Therefore, a violation of the Kelvin-Planck statement results in the violation of the Clausius statement. The Kelvin-Planck and the Clausius statements are equivalent in their consequence, and either statement can be used as the expression of the second law of thermodynamics. Any device that violates the Kelvin-Planck statement also violates the Clausius statement, and vice versa. Assuming that there is a machine that can transfer heat Q from a low temperature heat source to a high temperature object, and the machine does not consume work or produce other changes, then the entropy change of the isolated system, including the two constant temperature heat reservoirs and the machine, is less than 0. This violates the increase of entropy principle. However, the entropy of the isolated system cannot be reduced. Therefore, it is impossible to transfer heat from low temperature objects to high temperature objects without other changes. This means the first assumption violates Clausius' statement of the second law of thermodynamics. The correct should be a machine can transfer heat from a low temperature heat source to a high temperature object, and the machine must consume work or produce other changes. Furthermore, suppose that there is a heat engine which can obtain heat from a single heat reservoir and convert it into work after a cycle. According to the first law of thermodynamics, the amount of work equals to that of the heat. When the heat engine completes a cycle and the working medium returns to its original state, the entropy change of the entire isolated system, including the heat source and the heat engine, is less than 0. This violates the increase of entropy principle. However, the entropy of the isolated system cannot be reduced. Therefore, a cyclic engine that continuously does work using a single heat source is impossible. This is the Kelvin-Planck's statement of the second law of thermodynamics. Okay, that's all for this task. Thank you very much, and see you next time.